The 20th century witnessed humanity's mastery over the atom, but with it came a terrifying new power. This era marked a significant turning point in human history, where the potential for creation was matched by an equally potent capacity for destruction. Scientists, driven by curiosity and the pursuit of knowledge, unlocked the secrets of the atomic nucleus, unaware of the Pandora's box they were opening. This power could obliterate entire cities in a blinding flash. The sheer magnitude of destruction was unlike anything the world had ever seen. In an instant, bustling metropolises could be reduced to smoldering ruins, and the lives of countless individuals could be snuffed out in a heartbeat. The atomic bomb was not just a weapon, it was a harbinger of a new, more dangerous age. It could poison the land for generations. The aftermath of a nuclear explosion leaves a legacy of radiation that lingers long after the initial blast. This invisible menace seeps into the soil, contaminates water sources, and renders entire regions uninhabitable. The Chernobyl disaster serves as a grim reminder of the long-term consequences of nuclear technology gone awry. We built weapons of unimaginable destruction, atomic bombs and their even more powerful successors, hydrogen bombs. These devices harness the fundamental forces of the universe, releasing energy on a scale that defies comprehension. The hydrogen bomb in particular represents a quantum leap in destructive capability, capable of annihilating entire nations in a single cataclysmic event. These are not mere explosives. They are instruments of annihilation, fueled by the very forces that bind atoms together. The process of nuclear fission and fusion releases energy by splitting or combining atomic nuclei, unleashing a torrent of destructive power. This energy, once confined within the heart of stars, is now at humanity's fingertips, a double-edged sword of progress and peril. Understanding these weapons is not just about physics, it's about grasping their profound implications for life on Earth. The existence of nuclear weapons has reshaped geopolitics, instilling a constant undercurrent of fear and uncertainty. The potential for global annihilation has forced nations to tread carefully, knowing that a single misstep could trigger a chain reaction of destruction. The atomic bomb, first used in the closing days of World War II, unleashed the devastating power of nuclear fission. The bombings of Hiroshima and Nagasaki were not just military actions, they were profound moral and ethical dilemmas. The immediate loss of life was staggering, but the long-term effects of radiation exposure added another layer of suffering. These events marked the dawn of the nuclear age, a period defined by both awe and dread. This ushered in the nuclear age, a time of both unprecedented peril and scientific advancement. The threat of nuclear war loomed large, casting a shadow over the latter half of the 20th century. Yet this era also spurred remarkable technological progress, as the same principles that powered bombs were harnessed for peaceful purposes, such as nuclear energy and medical applications. But the development of the hydrogen bomb, fueled by nuclear fusion, marked a terrifying escalation. This new class of weaponry was exponentially more powerful than its predecessors, capable of producing explosions of unimaginable magnitude. The hydrogen bomb's creation was a testament to human ingenuity, but also a sobering reminder of our capacity for self-destruction. This weapon, with its vastly greater destructive yield, pushed the world to the brink. The Cold War era was characterized by a precarious balance of power, with the threat of mutual assured destruction serving as a deterrent against nuclear conflict. The specter of nuclear war influenced international relations, military strategies, and even popular culture, embedding itself in the collective consciousness of humanity. In response to this existential threat, movements for disarmament and peace emerged, advocating for a world free from the shadow of nuclear annihilation. Treaties and agreements were forged in an effort to curb the proliferation of these devastating weapons. The journey towards a safer world is ongoing, as the legacy of the nuclear age continues to shape our present and future. Today, the dual nature of nuclear technology remains a powerful symbol of human potential. On one hand, it offers solutions to some of our most pressing challenges, such as energy production and medical advancements. On the other, it serves as a stark reminder of the destructive capabilities we possess. The dawn of the nuclear era has forever altered the course of history, leaving an indelible mark on the human story. At the heart of the atomic bomb lies the principle of nuclear fission. This groundbreaking discovery, made in the early 20th century, revolutionized our understanding of atomic energy and its potential for both constructive and destructive purposes. In the simplest terms, fission is the splitting of an atom's nucleus, usually uranium or plutonium, into smaller fragments. When the nucleus of these heavy atoms splits, it releases a significant amount of energy, a concept that scientists like Lisa Meitner and Otto Hahn first uncovered. This splitting releases a tremendous amount of energy. To put it into perspective, the energy released from splitting just 1 kilogram of uranium is equivalent to burning several thousand tons of coal. This immense energy release is what makes nuclear fission so powerful and consequently so dangerous. Imagine a single drop of water setting off a raging inferno. This analogy helps us grasp the magnitude of the chain reaction that fission can initiate. A seemingly small event can lead to an enormous release of energy, much like how a tiny spark can ignite a massive fire. That's the power of fission. It's a process that can be harnessed for generating electricity in nuclear power plants, but when used in weapons, it unleashes unparalleled destruction. In an atomic bomb, this reaction is triggered by a neutron striking the nucleus of a heavy atom. This initial impact causes the nucleus to become unstable and split, releasing more neutrons that go on to strike other nuclei, perpetuating the cycle. This impact sets off a chain reaction, splitting more and more atoms in a fraction of a second. The speed and scale of this reaction are what make atomic bombs so devastating. Each split atom releases more neutrons, which in turn split more atoms, creating an exponential increase in energy release. The first atomic bombs, dropped on Hiroshima and Nagasaki, instantly killed hundreds of thousands. These bombings not only caused immediate destruction, but also had long-lasting effects on the health and environment of the affected areas. The blasts left behind radioactive fallout, poisoning survivors, and contaminating the environment for decades to come. The radiation exposure led to severe health issues, including cancer and genetic mutations, affecting generations of people. The world watched in horror, forever scarred by the dawn of the atomic age. The sheer destructive power of these weapons prompted a global reckoning with the ethical and moral implications of nuclear technology. It sparked debates on disarmament and the need for international treaties to prevent the proliferation of nuclear weapons. In the years that followed, nations around the world engaged in disarmament talks and signed treaties aimed at controlling the spread of nuclear weapons. The goal was to ensure that such devastating power would never be unleashed again. The legacy of Hiroshima and Nagasaki serves as a stark reminder of the catastrophic consequences of nuclear warfare and the importance of striving for a peaceful world. While the destructive potential of nuclear fission is undeniable, it's also important to recognize its peaceful applications. Nuclear energy, when harnessed responsibly, can provide a significant source of electricity with a relatively low environmental impact. The challenge lies in balancing the benefits of nuclear technology with the need to prevent its misuse. As we move forward, continued research and international cooperation are essential in ensuring that nuclear technology is used for the betterment of humanity. By learning from the past and working together, we can harness the power of the atom for a brighter, safer future. If the atomic bomb was a raging fire, the hydrogen bomb is the sun itself, burning with unimaginable intensity. It harnesses the power of nuclear fusion, the very process that fuels stars in the universe. Fusion involves fusing together light atomic nuclei, like isotopes of hydrogen, to create heavier elements like helium, releasing vast amounts of energy. This releases energy on a scale far greater than fission, exponentially more powerful. Imagine the force of 1,000 suns unleashed in an instant, a cataclysmic event. That's the terrifying reality of a hydrogen bomb, a weapon of mass destruction. These weapons, first tested in the 1950s, dwarf even the most powerful atomic bombs in destructive potential and sheer magnitude. They represent a quantum leap in humanity's capacity for self-destruction, a sobering thought. Section 4. Fission versus fusion, a tale of two reactions. Fission and fusion are two sides of the same nuclear coin, yet they operate in fundamentally different ways. Fission is about splitting heavy atoms, while fusion is about merging light ones. Picture fission as a demolition derby, atoms smashing into each other, releasing energy in the process. Fusion, on the other hand, is more like a delicate dance, requiring immense heat and pressure to force atoms to fuse and release their energy. Both processes have profound implications, but it's the sheer scale of fusion that makes the hydrogen bomb so terrifying. It represents a level of destructive power that is difficult to even comprehend. Section 5. The Shadow of Armageddon, Nuclear Weapons and Global Devastation. The destructive power of nuclear weapons extends far beyond their initial blast radius. The immediate effects of a nuclear detonation are horrifying. A blinding flash of light, a searing heat wave, and a shock wave that can level entire cities. But the devastation doesn't end there. Radioactive fallout, a toxic cocktail of radioactive particles, is carried by the wind and contaminates vast areas. This invisible killer can cause radiation sickness, cancer, and birth defects for generations. The environmental impact is equally devastating. Nuclear explosions release massive amounts of soot and debris into the atmosphere, potentially triggering a nuclear winter. This phenomenon, characterized by prolonged darkness and global cooling, could disrupt agriculture and lead to widespread famine. Section 6. The Ethical Abyss. Wrestling with the implications of nuclear power. The development of nuclear weapons opened a Pandora's box of ethical dilemmas. The Manhattan Project, which brought together some of the greatest scientific minds of the 20th century, was a monumental achievement in physics and engineering. However, it also marked the beginning of an era where humanity gained the unprecedented ability to annihilate itself. The image of Pandora's box is fitting, as it symbolizes the unleashing of forces that are beyond our control, forces that can bring about both progress and destruction. Can we as a species be trusted with the power to destroy ourselves many times over? This question has haunted policymakers, scientists, and citizens alike since the first nuclear tests. The sheer destructive capability of these weapons is almost incomprehensible. Each test, each explosion, serves as a grim reminder of the potential for catastrophe. The discussions and debates that have ensued over the decades reflect our deep-seated fears and ethical concerns. Is the deterrence provided by these weapons worth the risk of accidental detonation or intentional use? The doctrine of mutually assured destruction, or MAD, posits that the threat of total annihilation is what keeps nuclear powers in check. But this precarious balance is fraught with risks. Accidents, miscommunications, or rogue actors could trigger a chain of events leading to unimaginable consequences. The protests against nuclear weapons highlight the public's anxiety and the moral quandaries we face. These questions have no easy answers. The ethical dilemmas posed by nuclear weapons are complex and multifaceted. They force us to weigh the potential benefits of deterrence against the moral and existential risks. Philosophers, ethicists, and political leaders have grappled with these issues, often arriving at different conclusions. The debates are ongoing, reflecting the evolving nature of our understanding and the changing geopolitical landscape. The very existence of nuclear weapons challenges our morality and forces us to confront the potential consequences of our actions. The bombings of Hiroshima and Nagasaki serve as stark reminders of the human cost of nuclear warfare. The aftermath of these events continues to resonate, shaping our collective consciousness and fueling movements for disarmament and peace. The protests and advocacy efforts are a testament to the enduring desire for a world free from the shadow of nuclear annihilation. It is a heavy burden to bear, knowing that the fate of humanity may rest on a knife's edge. The Cold War era, with its intense nuclear tensions, exemplified this precarious balance. The world watched with bated breath as superpowers engaged in a high-stakes game of brinkmanship. The image of Earth balanced on a knife's edge captures the fragility of our existence and the immense responsibility that comes with wielding such power. The pursuit of peace and the prevention of nuclear war must be paramount. Diplomatic efforts, peace talks, and disarmament treaties are crucial steps toward reducing the nuclear threat. These initiatives represent the collective will to move away from the brink and toward a more secure and peaceful world. The protests and advocacy for disarmament underscore the importance of public engagement and the role of civil society in shaping policy. We must find ways to bridge ideological divides, foster dialogue, and build a safer world for ourselves and future generations. The United Nations and other international bodies play a vital role in facilitating dialogue and cooperation. By working together, we can address the root causes of conflict and build a foundation for lasting peace. The diverse group in dialogue symbolizes the potential for unity and collaboration in the face of shared challenges. Our collective efforts can pave the way for a future where the specter of nuclear war is a distant memory. Section 7. The Quest for Disarmament, a Fragile Hope in a World on Edge. Since the dawn of the nuclear age, there have been ongoing efforts to limit the proliferation of nuclear weapons and work towards their eventual elimination. Treaties like the Nuclear Non-Proliferation Treaty, or NPT, have sought to prevent the spread of these weapons to more countries. However, the path to disarmament is fraught with challenges. Geopolitical tensions, mistrust between nations, and the perceived security provided by nuclear deterrence pose significant obstacles. Despite these challenges, the pursuit of a world free from nuclear weapons must remain a global priority. The alternative is simply too horrific to contemplate.